Hi, my name is Bryson Cox, and today I'm going to be presenting over the Chernobyl disaster. So first we're going to look at the description of systems or products involved. So the main system and piece of equipment that was involved in Chernobyl was the RBMK 1000 reactor. This is a specific design of a reactor that at the time was mainly used in the Soviet Union. Even though Chernobyl was located in Ukraine, this was back in the time when Ukraine was still part of the Soviet Union. So this is the type of reactor that they used. And there were 4 reactors. Units 1 and 2 were built in 1970 and then 1977. And units 3 and 4 were both built in 1983. There is an artificial lake situated near the Pripyat River, which was a few kilometers away from the complex, and they use this river to pump in cooling water that help kind of cool down the reactors. And obviously the reason that it's called the Chernobyl Power Complex is because the town of Chernobyl was located only about 15 kilometers southeast of the complex. And then this right here is what one of the reactors looked like. So next we're going to talk about the operation and maintenance of the organization / personnel and or procedures. So the RBMK 1000 reactor is used to boil light water, which is then pumped to the bottom of heat channels. And to control power and reactivity, 211 rods are lowered into a moderator. And this is a picture of what it looked like. It says a light water graphite moderated reactor, or LWGR. That's the other type of reactor design that could also be used. But as I mentioned earlier, the Soviet Union primarily used the RBMK design. And right here you see the control rods that are all going down here, and that's what would be lowered down into the moderator. And all around here, these gray things right here, those are the moderators, and they would use graphite blocks, and then in between those graphite blocks they would pump nitrogen and helium, and it would help to kind of diffuse the heat and stuff that would be generated in here, and it would kind of help with the oxidation to help kind of keep things from overheating and all of that. So the RBMK utilizes a positive void coefficient. So the positive void coefficient is used whenever there's a bunch of steam being created. It helps with the power reactivity of the reactors and kind of helps to keep that under control. So this is the aftermath of the explosion that happened, and this is goes right in line with the narrative of key analysis and findings. So it might be a surprise to some people, but this whole explosion was actually the result of human error. There were shutdown mechanisms that were disabled by some of the crew preceding a routine test. Obviously those crew members weren't alerted of that routine test, so they started shutting stuff down whenever they didn't need to. And this caused a whole chain of events, and it ended up with an interaction between some hot fuel and cooling water, which led to a big buildup of steam pressure inside the reactor, and it eventually went up and it blew, and then it released toxic fissures into the atmosphere, which is what got everyone sick, and the atmosphere, it got them all caught with radiation and all of that. So some recommended hazard controls. The risk assessment code I've given this is a 1D, and I have a chart right here. So I've given it a 1 because it was catastrophic. I like to rate anything catastrophic if somebody was killed. And then right over here, D is seldom. I've said I gave it a 1 because 30 people were killed as a result, and then I gave it a D because it was rare for this to have occurred. there's a reason that this hasn't ever occurred again in history. So I think this is pretty rare, and I think we've done a pretty good job as a society of kind of learning from this mistake and knowing what to and what not to do when it comes to this. And some of the controls I would implement is, first off, I would implement an evacuation plan of anyone in the near vicinity. The complex had a radius of about 30 kilometers, so I would make sure and for sure get everyone out of there, like in Chernobyl or anywhere in those neighboring towns. I would make sure and get everyone out, and then after that I would have some certified cleanup teams come in and try and clean up all the radiation that they can to keep from any further spread happening. So in conclusion, the Chernobyl power complex used RBMK 1000 design reactors, and there were 4 of them, units 1 through 4, and the one that actually exploded was unit 4. And due to mechanism shutdowns, a power surge was created when the rods were inserted into the reactor, leading to a powerful explosion. And like I mentioned before, the explosion was caused by a big pressure buildup of steam whenever the hot fuel and the cooling water interacted, and it blew up the top of the reactor and exploded, and all the fissure, the chemicals and the radiation and all that was inside got dispersed into the atmosphere. And last but not least, a total of 30 people died as a result of this. 2 workers died on the scene immediately whenever it exploded, and the other 28 were actually first responders and people that got sick with the radiation poisoning from the fissures being out into the atmosphere, and 6 of those 30 were actually first responders that were firefighters. So this concludes my presentation of Chernobyl, and thank you for listening.